Students, till yesterday's class we discussed about simple series circuits, that is pure resistive, pure capacitive, pure inductive, RL, RC and RLC circuit. So today's topic will be somewhat different because here we are going to discuss about a parallel circuits, that is a resistor, inductor and capacitors connected in parallel, right? So to solve a circuit with parallel combination, then we are having three different modes, right? Let us see one by one, right? So for that purpose, let us consider a parallel combination of resistor, RL, RC circuit as shown in the figure. That is, let us consider a circuit where the resistor R1 and the series combination of R2 and L and the series combination of R3 and capacitor C farad are connected in parallel across voltage E is equals to Em sin omega t, due to which the current I is flowing through the circuit, right? So according to me, out of these three methods, the method of vector is somewhat very easier because we have already know how to draw the vector for R, L, C, RL, RC and RLC circuit. So it will be somewhat easier, right? So let me see. I will explain all the three methods, and whichever method you feel convenient, you can solve the problem using that method only, right? So let us discuss about method of vectors, right? So we know that whenever any of the electrical components connected in parallel, right, so voltage across them will remain same, right? So and the current across them will be gets divided, right? So here this circuit will be having three branches, hence I will be having three different currents, I1, I2 and I3. Let us evaluate the values of I1, I2, I3 and represent them in a particular vectors in a vector diagram, right? So first one, what is the value of I1, right? So we know that all these three components are connected in parallel across the voltage E, hence the voltage across each combination or each branch will be E only, that is E is equals to Em sin omega t. Therefore current I1 according to Ohm's law, V is equals to IR or I is equals to V by R. Here we know that voltage is E and resistance is R1, right? So in this case we know that both current and voltage will be in phase because it is pure resistive circuit, right? So therefore represent the vector I1 along x-axis, right? So because we know that always the phi will be what? Imaginary part divided by real part. Here in this equation I1 there is no imaginary term, therefore I1 is equals to 0 by R1, or which is nothing but 0, right? So phi is equals to tan inverse of 0 indicates phi is 0 only, that is both current and voltage are in phase, right? So another thing is what? You can see the current I1 is, it is flowing across resistor R1, it is a pure resistive circuit, right? So we know that in case of pure resistive circuit, both current and voltage are in phase. Similarly, we will evaluate the value of I2, that is it is a combination of R2 and L, that is it is a RL circuit, right? So in case of RL circuit, what we need to do? We need to calculate the value of Z, right? And we know that Z is equals to what? Under root of R square plus XL square. Here I have represented XL as X2, that is R square plus, R2 square plus X2 square, which is nothing but what? I2 is equals to E by Z2, that is E divided by under root of R2 square plus X2 square. And phi is what? Tan inverse of reactance divided by resistance, that is X2 divided by R2. Then how about the relation of angle with respect to voltage, right? So you can see here, what is the circuit consist of? It consists of resistor and inductor, right? So resistor and inductor, in that case always the current will be lagging by an angle of phi, right? So the current will be lagging by an angle of phi. Therefore we need to draw a vector in the fourth quadrant at an angle of phi 2, because it is lagging. Why it is lagging? It consists of R and L, right? So similarly we will go for current I3, right? So I3 is what? It is combination of, or the current flowing through R and C, right? So we know that Z3 is equals to what? Root of R3 square plus X3 square, that is resistance plus reactance. And similarly we can calculate current as E by Z3. Substitute the value of Z3, that is E divided by R3 square plus X3 square. Therefore phi 3 is equals to what? Tan inverse of X3 divided by R3. Then how about the nature of vector? Because this circuit consists of capacitor, right? So we know that whenever there is a capacitor in the circuit, then always the current will be leading. Therefore we need to draw the vector in first quadrant at an angle of phi 3, that is the current is leading by an angle of phi 3, right? So once we draw this vector, and we know what we need to do further, right? So we need to calculate summation of x and we need to calculate summation of y in order to calculate the resultant vector. What is summation of x? Right, so what is summation of x? Resolve all the components along x-axis, that is already I1 is along x-axis, therefore it is I1 cos 0, where cos 0 is 1, and I2 is in the fourth quadrant. If you resolve that into x and y components, you will get x component like this and y component like this, right? So here it is along positive x-axis, hence the value will be positive, that is I2 cos phi. Similarly I3, right? So I3 is here. If you resolve that into x and y component, you will get the vectors like this, resolved vector, right? So this vector is I3 cos phi, and as it is positive x along positive x-axis, we need to get it as the positive one, right? So similarly resolve the vectors along y component, that is y-axis, right? So see here, the vector I1 is along x-axis. If you resolve that along y-axis, you will get it as 0, right? So because it is along x-axis, summation of y is equals to 0, or if you want, you can write it as I3 sin 0, right? So sin 0 is 0, therefore total value is 0 itself. Next, go for second vector. See, the second vector is in fourth quadrant. If you resolve that along y component, the graph will be like this. As it is along negative y-axis, therefore we need to get a negative sign here. Negative I2 sin phi 2. Why negative? Because this is along negative y-axis when I am going to resolve it, right? So similarly I3 is here, right? So if you resolve that, I will get the vector along positive y-axis, hence it is positive I3 sin phi. Once you get the values of summation of x and summation of y, then you can calculate the resultant vector as under root of summation of x square plus summation of y square. That is phi r is equals to tan inverse of summation of y divided by summation of x. At last you need to represent this resultant vector also in your vector diagram, right? So regarding the vector operator j, we will discuss in the next class. Thank you.